Good morning to all. I am Karina from BSc Chemistry Honors Final Year. Today's our chapter is from Pradeep's Organic Chemistry book by Dr. S.N. Dhawan. Our topic is Terpenoids and Alkaloids. Terpenoids. Introduction. The terpenoids form a group of compounds, the majority of which occur in plant kingdom. Isolation of these substances from the various parts of plants, even from the food in some cases, by steam distillation or ether extraction gives what are known as essential oils. These are widely used in perfumery and food flavorings and medicines or as solvents. Among the typical essential oils are those obtained from cloves, roses, lavender, citronella, eucalyptus, peppermint, camphor, sandalwood, cedar, and turpentine. The chief constituents of essential oils which are obtained from the sap and tissues of certain plants and trees were originally called terpenes. However, these days the more general name terpenoids is used. The reason being that the suffix "ene" signifies unsaturated hydrocarbons and hence as such the name terpene is inappropriate to include compounds such as aldehydes, ketones, etc. However, the term terpene is now used only to represent hydrocarbons with molecular formula C10H16. Isoprene rule. The thermal decomposition of almost all terpenoids gives isoprene, 2-methyl-buta-1,3-diene C5H8 as one of the products. This suggests that the skeletal structure of all naturally occurring terpenoids are made up of isoprene units. This is called isoprene rule and was first pointed out by Welch in 1887. Thus, divisibility into isoprene units may be regarded as a necessary condition to be satisfied by the structure of any natural terpenoid. Thus, according to modern definition, terpenoids are hydrocarbons of plant origin having the general formula C5H8 whole N, where N equals to 2, 3, 4 and so on etc., as well as their oxygenated, hydrogenated and dehydrogenated derivatives. In 1925, it was pointed out by Ingold that the isoprene units in natural terpenoids were joined head to tail, the head being the branched end of the isoprene unit. This indivisibility into isoprene units and their head to tail union may be referred to as spatial isoprene rule. The carbon skeleton of open chain monoterpenoids and sesquiterpenoids showing head to tail union of isoprene units are shown below. However, it may be pointed out here that although this rule has proved very useful, yet it can only be used as a guiding principle and not as a fixed rule. Several exceptions to this rule are known. For example, in lavendiolol and erymophilone, in carotenoids, the isoprene units are joined tail to tail at the center. At the same time, there are some terpenoids whose carbon content is not a multiple of 5 and those whose carbon content is a multiple of 5 but cannot be divided into isoprene units. Classification. We have stated above that most natural terpenoid hydrocarbons have general formula C5H8N, where N equals to 2, 3, 4 and so on etc. It is this value of N which is used for classification of terpenoids as shown below. When N equals to 2, number of carbon atoms 10, molecular formula C10H16, class monoterpenoids. Examples: myxine, zeranil, alpha-terpineol, alpha-pinene, camphor, etc. C15H24, sesquiterpenoids. Examples: farnesol, zingiberine, alpha-cadenine, etc. Molecular formula C20H32, diterpenoids, phytol, abitic acid, etc. C25H40, cisterpenoids, solenisol. C30H48, triterpenoids, squalane. C40H64, tetraterpenoids or carotenoids. Examples: beta carotene in carrots and lycopene, red pigment of tomatoes. C5H8N polyterpenoids. Example: rubber. The sister terpenoids have been discovered only recently. The first example of this class is called solenisol, an acyclic unsaturated alcohol which was discovered in 1956. In addition to the hydrocarbons in each class as given in the above table oxygenated compounds like alcohols, aldehydes, ketones, also known, which occur in nature. Each class of terpenoids have been further divided into subclasses such as acyclic, monocyclic, bicyclic, tricyclic, tetracyclic terpenoids according as they have open chain structures or have 1, 2, 3 and 4 rings respectively. Some representative examples. Some representative examples of each class, their structures, source and chemical characteristics, if any, are summarized below. Monoterpenoids, acyclic. Myrcene, zeranol, nerol, linalool, citral A, nerol, citronellal, lavandulol. Monocyclic. Bicyclic. Some examples are given with their structures below. Sesquiterpenoids. The sesquiterpenoids are classified into 4 groups according to the number of rings present in the structure. If we use the isoprene rule, then when 3 isoprene units are linked head to tail to form an acyclic sesquiterpenoid hydrocarbon, the latter will contain 4 double bonds. Each isoprene unit contains 2 double bonds, but one disappears for each pair that is connected. When this open chain compound is converted into a monocyclic structure, another double bond is utilized in this process. So monocyclic sesquiterpenoid hydrocarbons contain 3 double bonds. In a similar way, it will be found that a bicyclic contains 2 double bonds and a tricyclic 1. Representative examples are farnesol, zingiberine, alpha-cadenine. Diterpenoids. Representative examples are phytol, C20H40O. It was obtained by hydrolysis of chlorophyll and it also forms part of the molecules of vitamin E and K. It is an acyclic diterpenoid. It has 2 chiral centers 7 and 11. Abiotic acid, C20H30O2 is a tricyclic diterpenoid. Triterpenoids. Squalene, C30H50 is an acyclic triterpenoid. It has been isolated from liver oils of sharks. Other sources are olive oil and several other vegetable oils. Tetraterpenoids, also called carotenoids. For example, beta-carotene C40H56 present in carrots and lycopene C40H56 which forms the red pigment of tomatoes. Alkaloids. Introduction. Originally, the name alkaloid, which means alkali-like, was given to all organic bases isolated from plants. This definition, being too broad, covers a wide variety of compounds. Therefore, this definition was changed. Conics in 1880 suggested that alkaloids should be defined as naturally occurring organic bases which contain a pyridine ring. This definition, however, includes only a limited number of compounds, and so the definition was again modified little later by Ladenburg, who defined alkaloids as natural plant compounds having basic character and containing at least one nitrogen atom in a heterocyclic ring. With the discovery of more alkaloids, 2 more characteristics were added to the above definition of alkaloids. These characteristics were complex molecular structure, significant physiological activity. Thus, alkaloids are now defined as complex nitrogenous compounds isolated from plants which are mostly optically active, levorotatory, and produces some specific physiological action when administered into the body. Extraction of alkaloids. Alkaloids are usually found in seeds, roots, leaves, or bark of the plant. They usually occur as salts of various plant acids such as acetic, oxalic, citric, malic, tartaric acid, etc. A common method of extraction involves the following steps. The plant is dried, then finely powdered, and then extracted with boiling methanol. The solvent is distilled off and the residue treated with inorganic acids, whereupon bases are extracted as their soluble salts. The free bases are then liberated by the addition of sodium carbonate and extracted with various solvents such as ether, chloroform, etc. The mixture of bases thus obtained are separated by various methods including chromatography. General properties. The alkaloids are usually colorless, crystalline, non-volatile solids which are insoluble in water but are soluble in ethanol, ether, chloroform, etc. Some alkaloids such as conine and nicotine are however liquids and a few are colored. Example, berberine is yellow. Most of the alkaloids have a bitter taste and are optically active, that is labiorotatory. They are usually tertiary nitrogen compounds and contain one or two nitrogen atoms, usually in the tertiary state in a ring system. Most of the alkaloids also contain oxygen. The optically active alkaloids such as quinine, brucine, etc. are very useful for resolving racemic acids. They form insoluble precipitates with solutions of phosphotungstic acid, phosphomolybdic acid, picric acid, potassium mercuric iodide, etc. Many of these precipitates have definite crystalline shapes and hence are used in the identification of alkaloids. These reagents are also used for detecting alkaloids in paper and thin layer chromatography. Classification of alkaloids. The most satisfactory method to classify alkaloids is according to the nature of the nucleus present in the molecule. For example, beta-phenylethylamine group, pyrrolidine group, pyridine and piperidine group, pyridine group, quinoline group, isoquinoline group, phenanthrene group, and indole group. There is no systematic nomenclature of alkaloids. Trivial names are used and these end in "ine", indicating a base, and usually indicate the source. Some important examples. The names, uses and structures of only simple alkaloids are given below. D minus amphitrine. It is an example of beta-phenylethyl group of alkaloids and occurs in genus Ephedra. It is one of the most important drugs in M. Huang, a Chinese drug. Physiologically, its action is similar to that of adrenaline and it can be taken orally. It has also been used in the treatment of hay fever, bronchial asthma, etc. It also increases blood pressure. It is a much stronger stimulant than caffeine. Adrenaline. Like D-amphetamine, adrenaline is also an example of beta-phenylethyl group of alkaloids. It is also regarded as a non-steroidal hormone. It is also called fight or flight hormone since it prepares animals and humans for emergency in many ways by raising the pulse rate, blood pressure, etc. It is also used locally to stop hemorrhage. However, it is active only when given by injection. Conine. It occurs in hemlock plant and was the first alkaloid to be synthesized. The oil of hemlock was drunk by Socrates, the great Athens philosopher, when he was condemned to death in 399 BC. Conine belongs to piperidine group of alkaloids. Piperine. It occurs in black pepper. It belongs to piperidine group of alkaloids. The stereochemistry about the two double bonds in trans-trans, the cis stereoisomer is called chevicine and is responsible for the sharp taste of black pepper. Nicotine. It is the most important member of pyridine-pyrrolidine group of alkaloids and occurs tobacco plant leaves. Natural nicotine is labiorotatory. Enough evidence is now available which shows that cigarette smoking increases the heartbeat and thus causes the constriction of blood vessels, resulting in an increase in blood pressure. It also promotes blood platelet coagulation, which is responsible for many coronary artery heart attacks. Atropine. This is the most important alkaloid of tropane group and occurs in the roots of deadly nightshade Atropa belladonna. Atropine. Atropine dilates the pupil of the eyes. Therefore, it finds extensive use in detection and treatment of ailments of the eyes. A single drop of solution containing 1 part of atropine in 14,000 parts of water is sufficient to dilate the pupil of the eye. Atropine has also been used to relieve the night sweats, which are a distressing feature of tuberculosis, and to reduce the activity of the salivary and gastric glands. Cocaine. This is an important member of coca group of alkaloids. It occurs in coca leaves and is used as a local anesthetic. Cocaine is a habit-forming drug and is therefore used for great care. Taken internally, it increases physical and mental power, but the after effect is deep depression. Continued use of cocaine causes hallucinations and eventually makes them insane. Quinine. It is the most important member of the Cinchona group of alkaloids. It is mainly used as a febrifuge and as an anti-malarial drug. Opium alkaloids. Many alkaloids have been isolated from opium and they are divided into two groups according to the nature of the structure. Isoquinoline group, example, papaverine, londanosine, etc. Phenylephrine group, example, morphine. Papaverine. It is one of the most optically inactive alkaloids as it does not contain any chiral carbon atom. It is a painkiller but has weaker physiological action than morphine. However, it finds use as antispasmodic for the relaxation of cardiac muscles and in the remedy for coughs. In small doses, it causes light sleep narcosis, while in larger doses, it causes tetanus and respiratory paralysis. Morphine. Opium contains alkaloids like morphine and codeine, which are very effective analgesics. Morphine triacetate, commonly known as heroin, is the most widely used analgesic. These are chiefly used for the relief of post-operative pain, cardiac pain, and pains of terminal cancer and in childbirth. However, these alkaloids are known to be habit-forming. Therefore, to guard against addiction misuse, these alkaloids are not sold without proper prescription. Reserpine. It is an important example of indole group of alkaloids. It is an isolated it is isolated from the Indian plant Rauwolfia serpentina. It is a powerful tranquilizer. It is also known as Serpacil. It slows down the pulse rate and lowers the blood pressure. Thank you.